Hey there, this is the second of two videos this week where we're looking at using some statistical tests to see whether differences between two groups are real or if they're likely just determined by chance. So in this example, we've got a prompt here that says you make handmade cosmetics and body care items that you sell online. You're experimenting with offering personalized product recommendations to shoppers on your website. You've created an experiment where you show personalized product recommendations to a random sample of website visitors. You've compiled a data set which shows 1, whether or not someone received product recommendations, and 2, how much they spent at your store. Used a paired t-test, assume unequal variances, to see if personalized product recommendations increase sales. Okay, legitimate question, right? So we've got a data set where we've got participants in column A. There are 40 participants. And then we've got our participants divided into two groups based on whether or not they saw product recommendations. As is customary, a 1 indicates a yes, right? They did see product recommendations, and a 0 indicates no, that they did not see product recommendations. And then in the third column, we have our total amount of sale, and this is measured in dollars. So the reason we're choosing a t-test here is because our dependent variable, the amount of money that they're going to spend, is a continuous variable, right? It's measured in dollars. 1 cent is twice as much as 2 cents, right? It's a number, and a larger number means they spent more. So we're going to use a t-test rather than a chi-squared test to tell if the difference is, well, is there a difference between people who saw product recommendations and people who didn't? And if so, is that difference likely to be random and determined by chance, or is it likely to be a real effect of whether or not they saw product recommendations? So to take on this t-test, we have to start by sorting our data by our treatment category. We want to take all the people who saw recommendations and separate them from the people who didn't. To do that, we're going to use the sort function in the data, and I'll start by highlighting my data. And then I will sort it by, did they see product recommendations? And it's going to sort on values from smallest to largest. And I say, okay, all right, so now here I go. I've got all the people who did not see product recommendations, all these zeros first. And then below that, I've got all the people who did see product recommendations, all those ones. And so what I'm going to do is I'm going to enter 2 rows. I'm going to enter 1 row here. And then above the amount of sale, I'm going to say, did not see recommendations. And then I'm going to scroll down till I find the first one, and I'm going to enter a row here. And I'm going to place the heading or the title of these people here, and I'm going to say received product recommendations. And then just to stay consistent with my formatting, I'm going to wrap this text. There we go. So on the top, I have people who did not see recommendations, and then on the bottom, I have people who received recommendations. And what we'd like to know is whether or not showing product recommendations increases the amount that people buy, because they've put their items in a cart, and then they would check out, but maybe if we show them some things that might be good based on what's in their cart, they might say, hey, oh yeah, I need that too, right? Does it work? That's what we want to know. So here we're going to do a t-test, and we're going to go into data, and we need this data analysis tab. If you don't have that, hit pause on this video and Google how to get it on your computer. And if you do have it, just keep going. We'll click data analysis tab, and you'll come up with a lot of choices. We're going to scroll down until we find t-test, to sample, assuming unequal variances. And then you're going to hit OK. This dialog box will pop up, and it has a variable 1 range, a variable 2 range. And those those titles refer to where is the data that we want analyzed. So our first variable 1 range is going to be the range of data where our first group is. And so we're going to say that here. That is the label and all the data for everyone who did not see product recommendations. My variable 2 range is going to be the data including the label, for everybody who did see product recommendations. So we've just said we want to compare those who did not, whose data is in C3 to C24, with those who did, whose data is in C25 to C44. And then the hypothesized mean difference, what do we think the difference is? We're always going to say 0. We're going to assume that difference is 0, and we want our t-test to say what are the odds that it's not. I've got labels here, and my alpha is 0.05, so that's with a 5% confidence interval. And then my output range, where do I want it to put that data? Or not the data, the results. I'm just going to say here, let's put it here in E3. And I will click OK. I'm going to make sure that these are all the right width. I know that they probably are. Okay, they're not. Now I can see everything. And here it is, a t-test to sample, assuming unequal variances. So what this does is it gives us the average, the mean. For those who did not see recommendations, the mean purchase amount was $69.83. I am a huge fan of formatting numbers in a way that makes sense, right? Whereas people who received product recommendations spent $89. So that actually seems like quite a significant difference, or a noticeable difference. We don't know if it's significant. And then here are variances. There's actually slightly more variation among those who did not see recommendations than there is among those who did. We've got 21 observations for those who did not see. We've got 19 recommendations for those who did, we've got 19 observations for those who did receive product recommendations. Then down here is the data that we're interested in. Particularly, what we'd like to know is the probability that this result is determined by chance, and that's given here with that two-tailed probability. And the numbers expressed with scientific notation with a negative 0.05, and what that's telling us is that it's a very small number. I'm going to put it in number format, and we can see that the probability here is way, way, way less than 1%. That probability indicating that these two are the same. So the probability that we got these two different means and that it's determined by random chance is very, very unlikely, right? That's telling us that we're seeing higher sales among those who receive product recommendations than those who don't, and that that difference is statistically significant. We could calculate this. We could create a calculation of lift, and lift would be the difference, $89 versus $69. So the benefit, the lift associated with product recommendations is about $19.16. That's pretty good. And as we can see here, it is statistically significant. It's unlikely, way less than 1% likely, that that difference, that lift is, that we'd see that if it didn't actually exist. So if I were to tell you in a text box what I think of this, which is what I want you to do, I want you to tell me what you think of this. I want you to say something along the lines of that product recommendations increase sales by about $19.16 per purchase. This difference is statistically significant. Statistically significant as measured using a t-test, where the probability that this result would have occurred by chance is 0.00002. I'm going to call that good. All right, and that's about what I would want you to say, right? So by showing product recommendations, we sell about $19.16 more per purchase, and that's a statistically significant result. If this was your business, I would recommend that you continue to show product recommendations because it is increasing sales. All right, let me know if you have any questions.